Now, I grabbed this file from decades ago that I've never done, so I can't actually locate where it is. I could probably maybe do a image search, but it is Hess's law to calculate the enthalpy of hydration of magnesium sulfate. So I haven't. This is just sort of like a feasibility to show that it works, and you can do it. It sent me down a little bit of a rabbit hole, which I don't mind doing. I think it's good for students just to be aware of certain things. And so hydration, just had to double check on that. So enthalpy of hydration is going from gaseous ions into water. And so that's not what you can see that we are trying to do. We're trying to actually work out how much energy from the solid anhydrate sulfate to the Epsom salts, the heptahydrate, and they're both in the solid form. So with a bit of research, the proper term for it should probably enthalpy of hydration of solid magnesium sulfate or enthalpy of crystallization to a hydrate. So technically, it's wrong to say hydration because enthalpy of hydration is not what we're doing. And there's enthalpy of solvation, which is just into any solvent. But if it's into water particularly, it's enthalpy of hydration. So enthalpy of hydration is a type of enthalpy of solvation. And what we're doing is we're going to do two enthalpy of solutions. So enthalpy of solution is a solid, liquid, or gas dissolving in water. And so we're going to do the magnesium sulfate anhydrate in water and then the magnesium sulfate hydrate in water. And using Hess's law, we can then do the enthalpy of hydration of a solid magnesium sulfate. And just to see if this one works, so that one of them should be like, I think we get the temperatures okay. So the students did both. And so the first one they did was fine. They got a calculation. It's all a little bit rough. So you can see that there, I just took just a very rough reading of how much it decreased for the endothermic, because it's quite obvious that it's Epsom salts heptahydrate because they're nice crystals, so you can trust them. And so they did that, and the calculations came up to about 2 degrees, which is not too bad. So that's 13 degrees. And what they were expecting to get was 18, 16, I think it is. Need to blow that up. And so that's okay, but I couldn't see any bottle of magnesium anhydrate. And I found the magnesium sulfate next to the manganese sulfate, so I think it was mislabeled. So I had to go back myself and make the anhydrate, which was very painful. So I got the crystals and I heated them up in the oven. And I didn't really heat them up for long enough because I lost patience for that too. So I really only put it in there for like an hour, just over an hour, and it wasn't really hot enough. You meant to do it for like 2 hours at like 250 degrees. I did reweigh it, which is better than what most people do on the internet, and it was only 15, and then I think it was got down to about 12. And I thought, oh, that'll do. And then I had the trouble that it wasn't cooling down. And as it cools down, it absorbs water. So it's quite a pain in the neck. I thought, oh, well, I'll just sort of get my water to maybe 30 or whatever it was within about 3 or 4 degrees, which is pretty bad because it's out by about 3 or 4 degrees. So I think it was within 2 degrees. And so once they were both around 27, I think it was, one was maybe 25, plus or minus a couple of degrees, I put them together. And this time I did it. It's nice using that big block of styrofoam because the temperature doesn't change, so I don't have to extrapolate back and do the temperature trick for rate of cooling. I can just take the last temperature. And so I just did some, because of all those massive errors, like plus or minus a couple of degrees, I just wanted to see if it generally will work. And so it was about 7. I think it's meant to be about 10 or 11. And it gives me minus 45. It's meant to be like minus, 84. So I'm out by 50%, which isn't too bad actually, considering my errors. So if you use Hess's law, you'll minus you'll minus those from each other, and you're meant to get minus 100, and I'll get like minus 60 or something, which is fine considering all the errors and how difficult it is to make the hydrate, which is probably a proper lab in itself. And so yeah, it works. It's quite good. All right, so I would recommend that. That was the first time we did it. So that was really a feasibility study, and I'm actually quite happy just if it's done like that and it gets those results, because we can well and truly account for the error that's going on.